I'm gonna give you a little bit of ETABS. Unit. When you open it, you need to choose unit, right? Okay, this is a model initiation document. So usually I'm using default. Say I open it. So it has a quick template. This is just sometimes helpful, sometimes doesn't help much. Depends on your building geometry, right? So the default has a story height 12. You can change it either 10 or 10. But how many floor, how many story? Here is a 4-story. XY spacing 20. Maybe make it 30 by 30. Maybe it's up to you. Maybe 40. Let's make a 40 and 30. Okay, number of grids. So okay, let's draw the grid. So we keep set up the grid, right? So since I pick up the default, the unit is imperial unit, right? So fit here, right? So first I'm gonna close the 3D. I'm gonna work on the plan. So story 4, maybe I'll go down to story 1. So it generates, because I plug in 4 stories, it generates all this plan and per each floor. All right, so on the plan view, story 1 and below is base. Base is a support foundation level, and story 1 is first floor. So now I'm gonna start with here, right? So material, obviously now what you need to start out is geometry, but maybe want to define the material. Are you working on a steel building or your concrete building or wood building? You need to know that what kind of material you're going to use. So go to define, here is a material properties, right? So material properties, we have a steel and concrete. So we're going to, these cases, I'm going to use a steel. So, okay, I'm going to use default steel grades 50. And section properties, default, they brought all this section, so I'm going to use it for now. So first thing is up to you, but usually draw the column first. So here, either go to draw, and then here, beam and column, right? So here you can draw the quick using draw column, which you have an icon here, right? Shortcut. So I click the shortcut. Okay, set up the property. Lateral column. Okay, this is group. I'll just choose one column. I'm going to choose, let's say, W8 by 40. Moment radius column, yes, I'm going to use continuous. So with this property, I'm going to draw the column at the intersection point, right? And then yes, escape key, I just come out. So I draw the column. How do I know? Put it in 3D so that you see the column, right? It's very easy. I'm recording anyway. I think I want you to practice 2-3 times. It's much no-brainer, easy to draw everything, mostly. Vertical, horizontal, member, ETABS is much easier than any other software because it is a building-oriented environment. So column and wall, vertical element, you draw and draw, right? I'll show you the wall here. I'll put it to the story 1. Let's say homework 1, if you want to draw the wall, I think here, quick draw. Default W1 is 12-inch wall, so I click here and draw, right click. So you draw the wall. You set escape key, you can draw the wall like this, right? But do I have to draw every wall, every floor? No, you can copy it, right? So now I'm just explaining this, either column and wall, if you select this. Since I set up the story, go to edit, here replicate, Control R, right? Here is a replicate, basically copy story. So I'm gonna copy this wall or column up to the story 4. Since I copy, somehow they copy the boundary condition here. And you know what? Let me select it. Oh, okay.
Good. Just get comfortable.
Okay.
Good.
Okay. Oh boy. Cheers. All right, and I'm gonna put this one assign join restraint, and no restraint. So this is kind of copy the column and wall, right? So I'm gonna delete that. So how you see this how it is. It's easy, really. Other than software, this is.
I'm sorry, what were the steps again? So you were recording.
Yeah, I'm recording.
Oh, okay.
So, okay, I think just at least pay attention. Think about the sequence, building the column and wall, vertical element, right? And then I'm gonna draw the beam. So I'm gonna put back to the plan view. So this is plan view. I'm gonna zoom in. So you see the column? I choose W8 by 40, right? So I'm gonna draw the beam. So there are too many. Oh, since maybe I can use this. I can click this. I choose one beam. This one is a property has a lateral beam. So I click this, right click. So I draw the beam like this. Or this one, yeah, this quick beam is, I think, yeah, they draw. You don't have to click it because they understand by using intersection point. If you have a grid, you hover your cursor. Yeah, you understand. So I click that, the line, so I add the beam. So let's see. So I draw the beam. I'm gonna turn on that extrusion. See that 3D rendering? Right? So this is kind of easy to draw the beam column now. Go to plans. Few stuff we're gonna do. And then filler beams. So let's say we need another beam. So here, quick secondary beam and extractions. I'm gonna add the 3 beams. If you hover, because we have a grid system, right? If I type 2, yeah, it shows the 2 dashed line. It's cool. I think this is, you're gonna love it. I mean, practice it. You can build nice 3D model graphically amazingly fast. So I click 2. All right. So, but yeah, this is again is a moment release pin because this secondary beam is simply supported beam. So first, so you see this, yeah, we already built this. Now I'm gonna add a slab, right? So going back to this. So this is still structure. What we're gonna do, what we're gonna define. I think we have a default section and deck section. This is metal deck slab. So it's like this. We're gonna study this metal deck, concrete deck slab. Because steel construction, we use this steel column, steel beam. We need a metal deck frame, like a formwork, but this is structural form. It's the tension forces. So this metal sheet, they just collocate it, kind of form it, right? After that, after they place on top of the beam, they weld it using some shear stuff, and then they put the concrete. It's a concrete slab, but sitting on the metal deck. That is a composite steel construction primary element. So we're gonna use property is a 3-inch metal deck. Default is a 3.5-inch concrete topping. So I'm gonna use this. I'm gonna draw. Okay, quick draw or square draw. Square, you define each corner. You can draw the slab like this, or if you have here. This one is not quite. Okay, it draw it. Right? So this one has, yeah, deck 1. Now, what I want to make sure is orientation. Deck should be perpendicular. So local axis. Oh, deck. Okay. So somehow I just click this, but I didn't change the local axis. Default is 0 when I click it. So metal deck 0 is running X direction, but it's not right? Because metal deck is formed this. Otherwise, it's a fall down. Like it has only stiffness in one direction, so you have to rotate 90 degrees. Right? Got it? Same thing, paper, if you have a foam like this, right? It has a stiffness in direction, one direction. Because you foam, this is metal deck, you have a foam like this, right? So the beam is here, let's say, this is beam and beam here. If you put this one, if this metal deck has a stiffness, so span, right? From here to here. But if you rotate it, it's fall down. Because yours, if your metal deck is spanning like this, your metal deck span should be this long. Our intention is this is a foam work. Metal deck has this geometry. You need to put this metal deck on top of series of the beam, right? This is physically, just when you see it, yes, makes sense. Right? So I'm gonna rotate it and run the model, and let's call it a day today. So here, so I'm gonna rotate or redraw it. But first of all, let me redraw it. So click this, and instead of 0 degrees and 90 degrees, I draw this, right? Okay, so self-weight deflection. So based upon this, I want you to practice up to here. This is A. This is geometry, but default, we have a dead load and live load self-weight. I'm gonna run the model and show you and the forces, and let's wrap up today. So very easy, and you could do any stuff. So, all right. So again, okay, 3D animation. So uniform self-weight of structure pushing down. Do you think it makes sense? Deformation? Cannot, right? That is first your observation. Okay, makes sense, right? Now. We should have a different music selection, but they don't have it. So now, okay, here it is. Now, moment diagram. Now, this is the similar to the trapped area because you've been designing steel beam a lot. Look at your steel class. You must learn how to steel beam design, okay? I think mostly problem statements that address it. Dead load is how much, live load is how much, using line load, right? And calculate the shear and bending moment diagram, bending moment. And you design the beam, right? So this is model I show you due to the self-weight of slab and steel, right? Pushing load along the beams generate a positive moment, right? WL square over 8. You remember that?
Yeah.
That's it. So because this is momentless, 0, 0 moment, 0, 0 moment, right? Yep.
That would be the compression with the tension. I'm trying to.
Now this is a bending moment. So bending moment, I'm showing dead load and bending moment. So pushing, we have some uniform dead load from the slab and steel, right? So pushing down. So moment when we draw is usually put on the tension side. So it's the bottom side. They draw the moment on the bottom, which is tension, right? So shear forces, because this is a uniform line load, right? So it should be single diagonal, right? So what you study, I think homework 2, yeah, we play with the point load, but this is more line load. ETABS, right? Calculate the self-weight. We're going to assign the uniform live load 100 PSF. They calculate the trip width and load it along this beam, right? They calculate shear force and bending moment. So this is 3D example I will send you, but I want you to do exercise from the scratch this much. If you know a few exercise, easy to draw the 3D.